Hey, it's Mrs. Lethe, and we are starting Lesson 3 on the 3 types of notation for electron configuration. Now, you will need your tail out, you'll need a periodic table out, and remember, this is a video, so any time that you need to stop and rewind or go over something or take time out to, write notes or do a problem, then make sure you do that. The nice thing is you can pause, you can restart, rewind, watch it again, anything like that. Do what you need to do. Okay, so we talked about the 3 rules for electron configuration. Now we're actually going to put them to use. Remember that you have to follow Aufbau's principle. The first type of notation that we have is called orbital notation. Orbital notation uses Aufbau's principle to show the exact order that electrons are going to occupy the orbitals. The example that we're going to use is nitrogen. Now, the first thing that you have to do is come up with the number of electrons that the element has. And how do you do that? Well, you look on the periodic table, look at the atomic number, and the atomic number for nitrogen is 7. So that tells us that nitrogen has 7 electrons. So here's what we're going to do. We're going to start first by showing electrons going into the first sublevel, which is, if we take a look at Aufbau's principle, the 1s. We always start with the 1s. Well, how many sublevels or orbitals does the 1s have? It only has one orbital. So we're going to draw one dash for the orbital and label it. And that orbital has to be completely filled with electrons before we can go on to the next. So we're going to put 2 electrons in there in opposite spins. Then we're going to go on to the next sublevel, which is the 2s. Next arrow. So the s is, even though it's in the second energy level, it's still an s orbital, so it only has one orbital. So we're going to have a 2s. And we're going to put 2 electrons in it. Since there is only one orbital, we have to fill up that orbital before we can go on. Now after the 2s, we're going to go on to the next arrow, and we're going to go into the 2p. Now 2p has how many orbitals? It has 3. So we want to draw 3 orbitals of equal energy, label them the 2p. And how many electrons do we have left? So we've used 4, we have 3. Following Hund's rule, we want to show 1 electron in each before we put in a second. And since we only have 3 electrons, we're only going to put 1 electron in each. So we have 3 unpaired electrons, which means that nitrogen can form 3 bonds. It's the significance to orbital notation. Okay, that's orbital notation. Our second type of notation is called electron configuration notation. In electron configuration notation, now we're going to arrange the electrons in order of main energy level so that the s sublevel or the s and p sublevels of the highest energy level are always on the very end. Now, this really becomes important when you start having that overlapping that takes place in Aufbau's principle. Let's look at nitrogen again, and very quickly we saw that there were 2 electrons in the 1s, we had 2 electrons in the 2s, and then we had 3 electrons in the 2p, 1 in each of those orbitals. That's orbital notation. In the electron configuration notation, now we write the energy level, the sublevel, and then we superscript the number of electrons that are in that sublevel. So the 1s has 2 electrons, and that's what we write, 1s2, and it's red. 1s2, not 1s squared, it's not math class. Next, we have 2s with 2 electrons, and then we have the 2p with 3 electrons. Sorry about the dogs barking in the background. Alright, now, next thing I want you to do is I want you to underline all the electrons in the highest energy level. So you have the first energy level, we have the second energy level, and obviously the second is higher than the first, so we're going to underline the second energy level. Why are we doing that? These electrons represent the valence electrons. Valence electrons are those electrons that are available for bonding. Make sure you write that down. Valence electrons are those electrons that are available for bonding. Those are the electrons that we see in the octet. Okay, so our next type of notation is called the electron dot notation or Lewis dot notation. Lewis dot notation is what we're going to refer to. Now, Lewis dot notation uses those valence electrons, which are the electrons in the S and P sublevels of the highest main energy level. Let's say this X represents any element. Now, normally we use the symbol of the element, but X is going to be our generic element. We can have a maximum of 8 electrons. In the Lewis dot notation, we are drawing dots to represent those 8 electrons. And we draw those dots around the symbol of the element. So if we have only, you can have as little as 1 electron and as many as 8. So if we have 1 electron, we're going to draw our electron dot in that first position. Second electron in the second position, third, fourth, fifth, sixth, seventh, and eighth. Okay, now nitrogen we're going to use again. So you use the symbol, oops, went too far. We use the symbol for nitrogen, and nitrogen's electron configuration notation was 1s2, 2s2, 2p6, or no, 2p3. All right, and we underline that. So how many valence electrons do we have? We have 5. So in our electron dot notation, that's what we want to do. We want to put our first electron in the first position, second position, third position, fourth position, and in the fifth position. And when you start pairing the electrons, you want to put the electrons close together. All right, now what does this show us? This shows us the unpaired. This is an unpaired, or it's also called a lone electron. And those electrons are available for bonding. Again, it shows us that nitrogen can form 3 bonds. Sometimes the orbital notation and the Lewis dot notation doesn't give us the same picture. And that's another lesson that we'll learn about when we talk about bonding. Okay, so let's do another one. Let's do sodium. Sodium well, the symbol for sodium is Na. On your periodic table has 11 electrons. Okay, so we're going to start with the 1s. S has 1 orbital. We're going to put in 2 electrons. We're going to now go into the 2s with 1 orbital, 2 more electrons. That's 4 electrons. After the 2s, we go into the 2p, and we are going to put in 1 electron in each before we put a second. Count up the number of electrons every so often. So we've used 2, 4, 6, 8, 10. We have 1 electron left. That electron is going to go into the 3s, 1 single electron. All right, electron configuration notation. We have the 1s2, 2s2, 2p6, 3s with 1 electron, The third highest energy level, I'm going to underline that. Don't mix it with the 2p6. Now, if you only have an S sublevel on your highest, that's all you're going to use. Remember, you can have as little as 1 electron and up to 8, but you cannot mix up 2 energy levels. All right, so you have the first, we have the third, second, and then the third. So we only want those electrons in the third. So therefore, sodium has how many electrons in its electron dot notation? We'll have only 1. So it can only form 1 bond. Okay, let's try one more. We're going to use gallium. Gallium has the symbol Ga, and it has 31 electrons. All right, starting with the 1s, we're going to put in 2 electrons. 2s, 1 orbital, 2 electrons. After the 2s, 2p has 3 orbitals, and we're going to fill that up with 6 electrons, 1 in each, before I go in and put in a second. After the 2p, we're going to go into the 3s with 2 electrons. After the 3s, we're going to go into the 3p, which has 6 electrons, 1 in each, before I go back and put in a second. Now, look at this. After the 3p, we're right here. After the 3p, we're going into the 4s. It's an S sublevel, so it only has 1 orbital. All right? So 4s, 1 orbital, but we're going to put 2 electrons in it. Now, after the 4s, we come up here to the 3d. D orbital, D sublevel, has 5 orbitals. 1, 2, 3, 4, and 5. Label that the 3d. And I'm going to put 1 electron in each before I put in a second. And when I do that, I'm going to count up the number of electrons, and I'll find that I have used 30 electrons right now. So I have 1 more. What comes after the 3d, you can see, is the 4p. 4p has how many orbitals? Yep, you're right. It has 3 orbitals. And we're going to put that 1 electron into the 4p. All right, now, electron configuration notation, remember, you're going to order according to main energy level. So we have the first energy level, 1s with 2 electrons. Second energy level, we have 2s2, 2p6. After the second energy level, we have the third, which is 3s2, 3p6, but notice in your orbital notation you have 3p6 followed by 4s, but you also have a 3d. You want to put all the third energy level together, so you have 3d10. Now put your fourth energy level together, 4s2 and then 4p1. And what does that do? That puts your valence electrons right at the very end. Underline your valence electrons. And how many do you have? We have 3. Gallium, the symbol, 3 electrons, 1, 2, and 3. So gallium can form 3 bonds. All right, here's what I want you to do. I want you to do the next ones on your own. Have them done when you come into class tomorrow. And we will go over any questions that you have with those in class. So I want you to do krypton, then sulfur and selenium, and then strontium and cobalt. And if you didn't get those, you can stop, rewind, play it again, and get those 5 done. So 5 of those I want you to do whenever you have them done when you come into class tomorrow. Okay, good for now.